Hello everyone, here are videos for civil engineering. Welcome to the channel Amazing Civil Engineering Studies. Here we have different videos on all topic of civil engineering. Please subscribe and press bell icon, like and share as many as possible. In this video we will learn about concrete, its manufacturing, types and proportion. What is concrete? Concrete is the final product resulting from mixing cement, aggregates, including sand, water, and mixtures. It is initially malleable in its wet state and solidifies over time, gaining strength and durability. The formula for producing concrete from its ingredients can be presented in the following equation. Concrete equals binding material plus fine and coarse aggregate plus water plus admixture, optional. In its simplest form, concrete is a mixture of paste and aggregates, or rocks. The paste, composed of Portland cement and water, coats the surface of the fine, small, and coarse, larger, aggregates. Through a chemical reaction called hydration, the paste hardens and gains strength to form the rock-like mass known as concrete. Within this process lies the key to a remarkable trait of concrete: it's plastic and malleable when newly mixed, strong and durable when hardened. These qualities explain why one material, concrete, can build skyscrapers, bridges, sidewalks, and superhighways, houses and dams. Proportioning. The key to achieving a strong, durable concrete rests in the careful proportioning and mixing of the ingredients. A mixture that does not have enough paste to fill all the voids between the aggregates will be difficult to place and will produce rough surfaces and porous concrete. A mixture with an excess of cement paste will be easy to place and will produce a smooth surface. However, the resulting concrete is not cost-effective and can more easily crack. Portland cement's chemistry comes to life in the presence of water. Cement and water form a paste that coats each particle of stone and sand, the aggregates. Through a chemical reaction called hydration, the cement paste hardens and gains strength. The quality of the paste determines the character of the concrete. The strength of the paste, in turn, depends on the ratio of water to cement. The water-cement ratio is the weight of the mixing water divided by the weight of the cement. High-quality concrete is produced by lowering the water-cement ratio as much as possible without sacrificing the workability of fresh concrete, allowing it to be properly placed, consolidated, and cured. A properly designed mixture possesses the desired workability for the fresh concrete and the required durability and strength for the hardened concrete. Typically, a mix is about 10 to 15% cement, 60 to 75% aggregate and 15 to 20% water. Entrained air in many concrete mixes may also take up another 5 to 8%. Other ingredients. Almost any natural water that is drinkable and has no pronounced taste or odor may be used as mixing water for concrete. Excessive impurities in mixing water not only may affect setting time and concrete strength, but can also cause efflorescence, staining, corrosion of reinforcement, volume instability, and reduced durability. Concrete mixture specifications usually set limits on chlorides, sulfates, alkalis, and solids in mixing water unless tests can be performed to determine the effect the impurity has on the final concrete. Although most drinking water is suitable for mixing concrete, aggregates are chosen carefully. Aggregates comprise 60 to 75% of the total volume of concrete. The type and size of aggregate used depends on the thickness and purpose of the final concrete product. Materials are mixed in specific proportions to obtain the required strength. Strength of mix is specified as M5, M10, M15, M20, M25, M30 etc., where M signifies mix and 5, 10, 15 etc. Their strength in MPa, N/mm2, Kn/m2. In United States, concrete strength is specified in SI, which is pounds per square inch. Water-cement ratio plays an important role which influences various properties such as workability, strength, and durability. Adequate water-cement ratio is required for production of workable concrete. What is the right water-cement ratio for mix design? A right water-cement ratio for concrete design will influence the compressive strength, permeability, and the overall durability of the concrete structure. The idea of WC ratio is that more the value, greater is the water content in the concrete and the cement paste becomes more dilute and vice versa. Different water-cement ratios. Different water-cement ratios are employed for different concrete applications. For high-quality concrete construction, a lower water-cement ratio of 0.4 is employed. For concrete construction like driveways and sidewalks, a WC ratio ranging from 0.6 to 0.7 is normally used. The practical range of water-cement ratio ranges from 0.3 to 0.8 that gives stiff and weak concrete respectively. Weak concrete means a fairly wet concrete. How to choose water-cement ratio? Based on the exposure conditions and requirements, the WC ratio is selected either by the customer or by the authority in charge. The WC ratio can be either taken from the available data or as recommended by the ACI or respective country standards followed. The Table 6.3.3 of ACI 211.1 gives the amount of water for concrete mix based on different slump value required and aggregate size used. Studies show that capillary pores start to connect with each other when WC is higher than 0.40. When WC is higher than 0.70, all capillary pores are connected. So most of the standards recommend 0.70 as the maximum value for WC ratio. Higher is the aggressiveness of the environment, lower should be the WC ratio. For concrete exposed to a very aggressive environment, the WC should be lower than 0.40. Water-cement ratio and concrete strength. The overall concrete strength is reduced with the increase in the water-cement ratio. Addition of more water gives dilute paste that has more pores at the micro level. These make the concrete weak and results in cracks and shrinkage issues. The aggregates and cement particles take the excess water that is present in concrete. This consumption is uncontrollable if a large excess of water is present in the concrete. Hence, separate water channels are created, resulting in bleeding on the surface. This creates weak zones in concrete that are susceptible to cracking under service loads. A lower water-cement ratio can contribute to a high-strength and high-quality concrete. But water-cement ratio alone cannot give a good concrete. A good mix proportion and quality aggregates and binding materials contribute to good mix design. A low water-cement ratio is hence one of the factors influencing good mix design. When water is mixed with materials, cement reacts with water and hydration reaction starts. This reaction helps ingredients to form a hard matrix that binds the materials together into a durable stone-like material. Concrete can be casted in any shape. Since it is a plastic material in fresh state, various shapes and sizes of forms or formworks are used to provide different shapes such as rectangular, circular, etc. Various structural members such as beams, slabs, footings, columns, lintels, etc. are constructed with concrete. What is grade of concrete? Grade of concrete denotes its strength required for construction. For example, M30 grade signifies that compressive strength required for construction is 30 MPa, N/mm2, Kn/m2. The first letter in grade M is the mix and 30 is the required strength in MPa. Based on various lab tests, grade of concrete is presented in mix proportions. For example, for M30 grade, the mix proportion can be 1:1:2, where 1 is the ratio of cement, 1 is the ratio of sand and 2 is the ratio of coarse aggregate based on volume or weight of materials. The strength is measured with concrete cube or cylinders by civil engineers at construction site. Cube or cylinders are made during casting of structural member and after hardening it is cured for 28 days. Then compressive strength test is conducted to find the strength. Regular grades of concrete are M15, M20, M25, etc. For plain cement concrete works, generally M15 is used. For reinforced concrete construction, minimum M20 grade of concrete are used. Grades of concrete. For normal grade of concrete. Concrete grade. Mix ratio compressive strength MPa, N/mm2. Psi. M5 1, 5, 10 5 MPa 725 Psi M 7.5 1, 4, 8. 7.5 MPa 1087 Psi M10 1, 3, 6 10 MPa 1450 Psi M15 1, 2, 4 15 MPa 2175 Psi M20 1, 1.5, 3 20 MPa 2900 Psi. Standard grade of concrete. Concrete grade. Mix ratio. Compressive strength MPa, N/mm2. Psi M25. 1, 1, 2. 25 MPa. 3625 Psi M30. Design mix. 30 MPa. 4350 Psi M35. Design mix. 35 MPa. 5075 Psi M40. Design mix. 40 MPa. 5800 Psi M45. Design mix. 45 MPa. 6525 Psi. High-strength concrete grades. Concrete grade. Mix ratio. Compressive strength MPa, N/mm2. Psi M50. Design mix. 50 MPa. 7250 Psi M55. Design mix. 55 MPa. 7975 Psi M60. Design mix. 60 MPa. 8700 Psi M65. Design mix. 65 MPa. 9425 Psi M70. Design mix. 70 MPa. 10150 Psi. How to make concrete. Concrete is manufactured or mixed in proportions WRT cement quantity. There are two types of concrete mixes, i.e. nominal mix and design mix. Nominal mix is used for normal construction works such as small residential buildings. Most popular nominal mix are in the proportion of 1:2:4. Design mixed concrete are those for which mix proportions are finalized based on various lab tests on cylinder or cube for its compressive strength. This process is also called as mix design. These tests are conducted to find suitable mix based on locally available material to obtain strength required as per structural design. A design mixed offers economy on use of ingredients. Once suitable mix proportions are known, then its ingredients are mixed in the ratio as selected. 2 Methods are used for mixing, i.e. hand mixing or machine mixing. Based on quantity and quality required, the suitable method of mixing is selected. In the hand mixing, each ingredients are placed on a flat surface and water is added and mixed with hand tools. In machine mixing, different types of machines are used. In this case, the ingredients are added in required quantity to mix and produce fresh concrete. Once it is mixed adequately, it is transported to casting location and poured in formworks. Various types of formworks are available, which is selected based on usage. Poured concrete is allowed to set in formworks for specified time based on type of structural member to gain sufficient strength. After removal of formwork, curing is done by various methods to make up the moisture loss due to evaporation. Hydration reaction requires moisture, which is responsible for setting and strength gain. So, curing is generally continued for minimum 7 days after removal of formwork. Types of concrete construction. Concrete is generally used in two types of construction. Plain concrete construction. Reinforced concrete construction. In Ppcc, it is poured and casted without use of any reinforcement. This is used when the structural member is subjected only to the compressive forces and not bending. When a structural member is subjected to bending, reinforcements are required to withstand tension forces structural member, as it is very weak in tension compared to compression. Generally, strength of concrete in tension is only 10% of its strength in compression. It is used as a construction material for almost all types of structures, such as residential concrete buildings, industrial structures, dams, roads, tunnels, multi-story buildings, skyscrapers, bridges, sidewalks, and superhighways, etc. Example of famous and large structures made with concrete are Hoover Dam, Panama Canal, and Roman Pantheon. It is the largest human-made building materials used for construction. Steps of concrete construction. The construction steps are: selecting quantities of materials for selected mix proportion. Mixing. Checking of workability. Transportation. Pouring in formwork for casting. Vibrating for proper compaction. Removal of formwork after suitable time. Curing member with suitable methods and required time. Types of concrete mix. Concrete is employed for various projects, starting from little homemade comes to large subject field buildings and structures. It is used for sidewalks, basements, floors, walls, and pillars at the site of several alternative uses. Many sorts of concrete are utilized in the development works. Different types of concrete. 1. Air-entrained concrete. 2. Decorative concrete. 3. Dry lean concrete. Roller compacted concrete. 4. Asphalt concrete. 4.1 Cold mix asphalt. 4.2 hot mix asphalt, 4.3 warm mix asphalt, 5 Ferro-Cement concrete, 6 fiber reinforced concrete, FRC, 7 fly ash concrete, 8 glass concrete, 9 high density concrete, 10 high strength concrete, 11 insulating concrete, 12 lightweight concrete, 13 lime concrete, 14 normal strength concrete, 15 permeable concrete, 16 pervious concrete, 17 plain or ordinary concrete, 18 plumb concrete, 19 polymer concrete, 19.1 partially impregnated and surface-coated polymer concrete, 19.2 polymer impregnated concrete, PIC, 19.3 polymer Portland cement concrete, Ppcc, 19.4 polymer concrete, PC, 20 pre-stressed concrete, 21 precast concrete, 22 pre-packed concrete, 23 rapid hardening concrete, 24 ready mix concrete, 25 reinforced concrete, 26 stamped concrete, 27 self-compacting concrete, 28 Shotcrete concrete, 29 Silica Fume concrete, 30 smart concrete, 1 air-entrained concrete. These are concrete types to which air is intentionally entrained for a period of 3 to 6% of the concrete. The air entrainment from the concrete is achieved by the addition of foams or gas foaming agents. A few examples of air entraining agents are resins, alcohols, and fatty acids. Air entrained concrete density 1840 to 2400 kgm3. 2 decorative concrete. Decorative concrete in the form of concrete that has been treated in many different ways to increase its aesthetic appeal. For instance, it may go through procedures like coloring, texturing, molding, polishing, embossing, etching, embedding items, applying decorative toppings, and so on. Various materials are used in producing decorative concrete, like color hardener that offers a unique color as well as a highly durable surface. Integral color is usable on any texture and application. It's also utilized to add components of dynamism to unexciting surfaces as well as material. Some common applications include decorative flooring, swimming pools, paving, and 3 dry lean concrete roller compacted concrete. These are concrete that's placed and compacted with the help of earth-moving equipment like heavy rollers. This concrete is mainly employed in excavation and filling needs. These concretes have cement content in a lesser amount and filled to your area necessary. After compaction, this concrete provides high density and finally cures into a strong monolithic block. 4 asphalt concrete. Asphalt concrete, more commonly called just asphalt, is a composite material used in the construction of roads, highways, airports, parking lots, and other kinds of pavements. The use of asphalt for street construction began in the late 1800s, and the market for asphalt expanded as the automobile industry grew. Since then, there have been enormous strides in the development of asphalt technology. Today, highly sophisticated equipment and processes are used to construct asphalt pavements. Asphalt is known to carry a number of desirable properties like durability, workability, fatigue resistance, skid resistance, stability, impermeability, and flexibility. But to make sure that these properties function, asphalt concrete mixture has to be properly designed, produced, and placed. Different kinds of asphalt mixes are designed to serve various functions. For instance, the base asphalt mixes have entirely different functions in pavement structure than asphalt surface mixes. Thus, both are produced differently. Various different kinds of asphalt concrete mixes are available to create unique structures. For instance, the asphalt mix used in the construction of roads must withstand tough weather conditions and high traffic. Thus, to cope with the applied pressure from vehicle wheels, it ought to be sufficiently stiff, and to resist cracking exerted by other pressures, it ought to possess adequate flexural strength. Hot mix asphalt is the ideal mix for these high-traffic roads. Following are the three different kinds of asphalt mixes available. 4.1. Cold mix asphalt. Cold mix asphalt is widely used for roads with lighter vehicle traffic. Its production does not require heating as it uses a specific bitumen emulsion. The emulsion breaks during compaction or mixing and coats the aggregate. Over time, this coating increases the asphalt's strength. 4.2 Hot mix asphalt. Hot mix asphalt is produced in extremely high temperatures between 150 degrees Celsius and 190 degrees Celsius. Based on the usage, various mixtures can be made, including porous asphalt, asphalt concrete for very thin layers, double-layered porous asphalt, and so on. 4.3 Warm mix asphalt. Unlike hot mix asphalt, warm mix asphalt uses lesser energy and is produced in 20 degrees Celsius into 40 degrees Celsius of temperatures. The temperature is low during the paving operations, ensuring safety for the working team and earlier opening of the road to be used. 5. Ferro-Cement concrete. Ferro-Cement concrete shouldn't be confused with fiber concrete. Ferro-Cement consists of closely spaced wire meshes that are impregnated with a mix of cement mortar. Usually, 0.5 to 1 mm diameter steel wires are shaped into meshes. Mortar 1:2 to 1:3 using a water-cement ratio of 0.4 to 0.45 is poured to the formwork with fabricated steel by using layers of the wire mesh. The steel content of the concrete will be as high as 300 to 500 kg M30F mortar. As the material consists of a large percentage of steel, it has high ductility and tensile strength. The material was developed in 1940 by the Italian architect P. L. Nervi to build a large number of pleasing structural forms. 6. Fiber reinforced concrete, FRC. It is that type of concrete where steel fibers 10 to 20 microns in diameter and 10 to 50 mm in length are used. Fiber increases resilience, tensile strength, flexibility, along with other qualities. The fibers may be of different materials such as steel, polymer, glass, carbon, or even natural fibers such as coconut fiber. Some types of fibers react with the cement. Special care ought to be taken while using them. It has been used mostly as overlays for pavements in airports, bridges, and more than industrial floors. Fiber-reinforced concrete may also be used in places where increased resistance to cracking is required. 7. Fly ash concrete. Concrete with fly ash is known as fly ash concrete. Fly ash is obtained from coals. Fly ash may be used to replace fine aggregates or cement or to replace partially both. As much as 30% replacement of fine aggregates and 20% replacement of cement are reported. Fly ash improves workability from the fresh concrete and strength and durability within hardened concrete. The particles of fly ash must be finer than of cement particles. 8. Glass concrete. If the recycled glass is used as an aggregate in the concrete, this kind of concrete is called glass concrete. They provide better thermal insulation and also have a great appealing look as compared to other types. 9. High-density concrete. This type of concrete can also be called heavyweight concrete. Within this concrete type, the density varies between 3,000 to 4,000 kgm3. These kinds of concrete are prepared by using high-density crushed rocks as coarse aggregates. One of such materials, barytes, is the most widely used material, that has a specific gravity of 4.5. They are mostly used in atomic power plants and other similar structures because it provides good protection from all kind of radiations. 10. High-strength concrete. This concrete conforms to a particular standard but in no case will be limited to strength. It has to be noted that all the high-strength concrete could be a high-performance type. However, not all high-performance concrete, HPC, are high-strength concrete. Standards that conform to this high-performance concrete are enlisted below. Environmental concerns. Toughness and life-term mechanical properties. Long life and durability. Heat of hydration. Permeability and density factors. Easy placement of the concrete. Strength gain in early age. 11. Insulating concrete. As its name suggests, insulating concrete form systems provide insulating properties such as the concrete walls of a structure below and above grade. In residential construction, Regular concrete foundation walls often require the installation of insulation after the forms are removed. With ICFs, since the insulation remains in place, the insulation installation isn't required. Insulated concrete forms are lightweight, and lots of systems are erected like toy building blocks, making them easy to install. Insulating concrete forms may be used for residential below-grade foundations and above-grade walls up to 2 stories. Engineering designs could be required for larger structures. 12. Lightweight concrete. Concrete which has a density lesser than 1,920 kg M3 will be categorized as lightweight concrete. Using lightweight aggregates in concrete design will give us lightweight aggregates. Aggregates will be an important element that contributes to the density of the concrete. The examples of lightweight aggregates are the pumice, perlites, and scoria. The lightweight concrete is applied for the protection of the steel structures and can also be used for the construction of the long-span bridge decks. These can also be used for the construction of the building blocks. Lightweight concrete density 1,440 1920 kg M3. 13. Lime concrete. In this kind of concrete, lime can be used as a binding material with the aggregates. Before the invention of cement, the most used concrete was lime concrete. The most important application of this product is on floors, domes as well as vaults. These, unlike cement, have lots of environmental and health benefits. These products are renewable and easily cleaned. 14. Normal strength concrete. The concrete that's obtained by mixing the fundamental ingredients cement, aggregate, and water will give us normal strength concrete. The strength of this kind of concrete will be different from 10 MPa to 40 MPa. The normal strength concrete comes with an initial setting time of 30 to 90 minutes, which is dependent on the cement properties and the weather conditions of the construction site. 15. Permeable concrete. Permeable concrete is ready in such a manner that the water could be passed inside. They have about 15 to 20% voids so that the water may pass inside. They are used in those areas where storm water issues persist. 16. Pervious concrete. Pervious concrete is another type of concrete used in the construction of roads and pavements. It's designed to overcome the problems of storm water runoff and replenishment of local watersheds. Pervious concrete has the capability to absorb water rather than allowing it to puddle. This helps reduce hydroplaning, snow buildup, and tire spray, making the pavements safer for pedestrians and drivers. This also helps reduce the need for storm sewers and curbing. It is the structure of the concrete which gives it the property of water absorption. Like other kinds of concrete, pervious concrete is made of a mixture of cement, water, and coarse aggregates. However, the mix contains no sand, leading to a porous open-scale structure, allowing water to pass through easily. Some kinds of porous pavement made from pervious concrete may allow 3 to 5 gallons of water to pass through per minute, making it an ideal structure to control storm water drainage. Pervious concrete pavements also offer improved filtration and the ideal amount of surface area to catch chemical pollutants and oil, which is not the case with traditional asphalt or concrete. While pervious concrete is ideal for pavements and low-volume applications like residential streets and parking lots, it is not appropriate for full-scale use on high-traffic roadways. This is because its void structure does not have load-bearing properties that other kinds of concrete possess. 17. Plain or ordinary concrete. The plain concrete will have no reinforcement within it. The main constituents are cement, aggregates, and water. The most commonly used mix design is 1:2:4, that's the normal mix design. The density of the plain or ordinary concrete will vary between 2,200 and 2,500 kg M3. The compressive strength is 200 to 500 kg/cm2. These kinds of concrete are mainly utilized in the construction of the pavements along with the buildings, especially in areas where there is less demand for high tensile strength. The durability given by these kinds of concrete is satisfactory to a high extent. Plain or ordinary concrete density, 2,200–500 kg M3. 18. Plumb Concrete. In some mass concrete foundations, boulders of say 150 mm size up to 30% of the total quantity of concrete, are mixed in the wet concrete. This adds to economics and saves heat generation. Such concretes are called plumb concretes. After at least 2 layers of wet concrete is completed, well shaped, and thoroughly washed, angular rock pieces using a maximum size of not more than 60% of a layer of pore thickness are placed in the concrete. Keeping a distance of more than 1.5 times of the biggest size of aggregates in the concrete. The bottom of the boulders should be embedded in the wet concrete to avoid voids at the bottom. Concreting is continued without stopping. These rock pieces become an integral part of a concrete structure. 19. Polymer concrete. Polymerization is a process of conversion of monomers to polymers. In normal concrete, you need to have seen that micropores can't be avoided. The impregnation of monomer to those pores and subsequent polymerization is the technique that's been developed recently to reduce the porosity of the concrete and to improve its strength and other properties. The following are the 4 kinds of polymer concrete materials available at present. 19.1 Partially impregnated and surface-coated polymer concrete. This name is self-explanatory. These materials at present are mostly used in building construction only to improve durability or repairs works. 19.2 Polymer impregnated concrete, PIC. This concrete type is ordinary cured concrete, that can be dried in an oven, as well as the air at the open cells, is removed from the vacuum. A low viscosity monomer is introduced into these spaces, which is then polymerized by the application of chemical heat or action or by using radiation. 19.3 Polymer Portland Cement Concrete, Ppcc. These kinds of concrete are made by mixing a monomer along with the mixing of aggregates, cement, and water. However, the concrete obtained in this way isn't as strong as the impregnated type. 19.4 Polymer Concrete, PC. In this kind of concrete, instead of cement, the polymer can be used using the aggregates. It's not a true concrete as used in civil engineering terminology. 20 Pre-stressed concrete. Most of the mega-concrete projects are carried out through pre-stressed concrete units. This is a special technique where the bars or the tendons used in the concrete are stressed before the actual service load application. Throughout the mixing and the placing of the concrete, these tensioned bars placed firmly and held from every end of the structural unit. When the concrete sets and harden, the structural unit will be put in compression. This phenomenon of pre-stressing will make the lower section of the concrete member to be stronger against the tension. The process of pre-stressing will require heavy equipment and labor skill, jacks and equipment such as tensioning. Therefore the pre-stressing units are made at the and assembled at site. These are used in the application of bridges, heavily loaded structures, and roof with longer spans. 21 Precast Concrete. Various structural elements could be made and cast in the factory as per the specifications and brought into the site in the time of assembly. Such concrete units are known as the precast concrete. The examples of precast concrete units are concrete blocks, the staircase units, precast walls and poles, concrete lintels, and many other elements. These units have the advantage of acquiring speedy construction as the only assemblage is necessary. As the manufacturing is done on the site, quality is assured. The only precaution taken is for their transportation. 22 Pre-packed concrete. Usually, concrete is prepared by mixing different ingredients. But it's also possible to pack some of the ingredients, coarse aggregate, from the formwork and then fill the pores using specially prepared cement sand grout so that it will fill all the pores and form a concrete mass. Pre-packed concrete is used in special situations like in which a large volume of concrete, such as a large machine block foundation, has to be concreted without construction joints. One of the advantages of pre-packed concrete is that it has very little shrinkage. 23 Rapid hardening concrete. As its name implies, these concretes will acquire strength with few hours after its manufacture. Thus the formwork removal is made easy and thus the building construction is covered fastly. These have widespread application from the road repairs since they may be reused following few hours. 24 Ready-mix concrete. The concrete that mixes and bathed in a central mixing plant is known as ready-mix concrete. The mixed concrete is brought into the site with the help of a truck-mounted transit mixer. This, once reached in the site, may be used directly without any further treatment. The ready-mix concrete is very precise, and specialty concrete could be developed depending on the specification with utmost quality. The manufacture of that concrete will require a centralized mixing plant. These plants will be located at an adjustable distance from the construction site. If the transportation is too long, then it will result in setting of concrete. Such issues of time delay are coped up with the use of retarding agents that delay the setting. 25 Reinforced concrete. It's also called RCC, reinforced cement concrete. Within this concrete type, steel in various forms can be used as reinforcement to give very high tensile strength. In fact, it is due to the combined action of plain concrete, having high compressive strength, and steel, having high tensile strength. The steel reinforcement is cast in the form of bars, sticks, meshes, and all conceivable shapes. Every care is taken to ensure the maximum bond between the reinforcement and the concrete through the setting and hardening process. Therefore, the resulting material, RCC, is capable of bearing all kinds of stress in any type of construction. RCC is the most important concrete type. 26 Stamped concrete. Stamped concrete is an architectural concrete where realistic patterns similar to natural stones, granites, and tiles can be obtained by placing an impression of professional stamping pads. This stamping is performed on the concrete if it's in its plastic condition. Different coloring, stains and texture work will finally give a finish that's very like costlier natural stones. A high aesthetic look can be obtained from a stamped finish economically. This can be used in the construction of driveways, interior floors, and patios. 27 Self-compacting concrete. The concrete mix, when placed, will compact with its own weight, is regarded as self-compacting concrete. No vibration has to be provided for the same separately. This mix has higher workability. The slump value will be between 650 and 750. This concrete, due to its higher workability, can also be known as flowing concrete. The areas where there is thick reinforcement, self-compacting concrete works best. 28 Shotcrete concrete. Shotcrete is a concrete prepared in the same manner as ordinary, however, the difference is that they are placed differently. They're placed with the help of higher air pressure through nozzles. The benefit of this technique is that the compaction and placing of concrete will be done simultaneously. 29 Silica fume concrete. Silica fume is a byproduct of silica that's very finely divided into the industry. The concrete where silica fume can be used is known as silica fume concrete. The typical concrete using a normal water-cement ratio always has micropores, which limits the strength of regular concrete. Silica fumes consist of very fine particles, actually, 6 times finer than of cement particles. Hence, if it is added to the concrete mix, the minute pore spaces can be reduced, resulting in high-strength concrete. Silica fume can be a pozzolana, which will contribute to the strength. Therefore, silica fume, along with superplasticizers, is a necessary component of high-performance and high-strength concrete. 30. Smart concrete. Smart concrete technology offers an alternative method for monitoring the health of reinforced concrete structures. It works by adding a small quantity of short carbon fiber to concrete using a conventional concrete mixer that modifies the electrical resistance of the concrete in response to stress or strain. This may be used to monitor stress or strain from concrete structures, identifying potential problems before the concrete fails. Smart concrete is capable of sensing very small structural flaws and hence finds application in checking the internal condition of constructions, particularly after an earthquake. Smart concrete technology has undergone extensive laboratory testing, however, is yet to hit the market. 31. Vacuum concrete. Vacuum concrete in the form of concrete where the excess water has been removed to improve concrete strength. All the water used for mixing isn't required for hydration, so it's removed before hardening takes place. To remove the water, vacuum pumps containing vacuum mats are generally used. Not only is the final strength of this vacuum concrete improved by 25%, but its stiffening pace also improves such that the formworks could be removed within 30 minutes of casting even on high columns. This allows frequent reuse of forms, making it extremely economical. Vacuum concrete is characterized by higher density and increased bond strength. It can also be used for resurfacing old surfaces since it bonds well with old concrete. Vacuum concrete is ideal for structures that frequently subject to flowing water at high velocity. This is because the uppermost 1/16 inch of its surface is highly resistant to abrasion and the whole surface is usually free of pitting. Hope you like the video. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.